For lab 3, we use law, momentum principle, and gravitational force to determine the mass of a black hole by rearranging our known equations. And we mainly rearranged our equation for net forces of an orbiting star. As we can see from this picture, we do have that star's position, and we have those forces coming off of it. So we're able to easily do this using GlowScript. So for our formulas, we used Newton's second law. So we had a few different rearranged equations of this. So delta P equals F net times delta T, and we're able to set F net equal to dP over dt. So we're then able to set dP over dt equal to delta P over delta T. And then we also have, again, this net force acting on the star. We have our F gravitational force, and we can set the F net equal to F net, or F gravitational. And then we also can get our F net parallel and F net perpendicular, our different directional net forces, in order to get that full F net for our mass of the black hole equation, which again is mainly that rearranged net force acting on the star. So for our first section, all we really did here was input our email address to get our unique star trajectory right here. For section 2, we just inputted our gravitational constant, 6.7 times 10 to the negative 11. And for our third part is where we start to input a few more values. So we did our star mass, 2 times 10 to the 30th, and our delta T, so that's seconds in the day, so 86,400 seconds. And then down here we start to input our different equations. We got our P initial, P final, which we then use for our delta V and delta P equations down here. Okay, and then from our delta V and delta P, we're able to get that dP over dt, which we can then set equal to F net. And then as we continue down, so we're kind of going down this line solving for the different variables needed for the next line of code. So we then need to calculate our dP over dt parallel to get that parallel directional F net. And so this next part, we're then setting our F net parallel equal to dP dt parallel. And we can do the same thing for perpendicular down here once solving using our dP dt parallel. So then we are able to use all these different values that we got to get our F net here to solve for our mass of the black hole. And then down here, we're able to set the different arrows equal to our different directional forces for our computational model. So from our computational model, we have the F net orange arrow, F net parallel pink arrow right here, then our F net perpendicular blue arrow. As you can see, as it rotates around, those different forces are changing and can help us to calculate that mass as we did. So for the results, we're able to get the mass of the black hole is 1.18576 times 10 to the 34. And we're also given those different F net values and F net directional values that we did use to calculate this mass of the black hole. So what if and what does it mean? So what does it mean? So we were asked if F net and momentum are the same values, which they are. However, they also are not. So we can see that they're the same through the F net equals dP over dt. However, there is a difference because we first calculated our dP over dt to then get our F net. So in this lab, we were unable to get our net force without the mass. So we used our dP dt to first get our F net value in order to then calculate mass. So these do end up being the same values in the lab. However, we are unable to calculate F net just by itself without using dP dt instead. And so what if? So if we're given a new mass, we're unable to calculate the value of that new mass because we're given the same positioning for the star's motion. And if we're given the same value of the motion, when we try to solve for this new mass, we're going to end up getting the same mass as before, since, again, we are not changing the position of the star, and we're using just our star position to calculate the mass originally. So critiques and conclusions. So critiques, I did have some issues during the coding portion of this lab. It errored a couple times, but however, I did some small adjustments in order to fix that. I also had some problems adjusting my arrow scale to get those F net directional arrows, but eventually I was able to figure this out and get those 3 different arrows in those different directional F nets. So for the conclusion, so through our knowledge of Newton's second law and gravitational forces, we were able to successfully calculate the mass of the object, again, based on that position of the orbiting star, through reworking our momentum and our Newton's second law equations and our gravitational forces equations. So by knowing our directional momentums, we can find our F net value in order to find what our mass is. And through linking and reworking equations, we're able to successfully get this mass. However, as we did discuss in the what if statement, we can only get one mass for each directional path that we are given due to using position to